Hi, I'm Sensei Allison from Code Ninjas Wellesley, and today we'll be talking about how to write code that the computer only executes in specific situations. This is the second JavaScript concept kata. The series begins with variables. You know those annoying times when your mom or dad tells you that you can only play video games or hang out with your friends if you finish taking out the trash or doing the dishes? Think about what happens if you do finish your chores. You get to have fun. Think about what happens if you don't finish them. No fun for you. In the first case, the statement, you finish your chores, is true. In the second case, it's false. You only get to do the fun activity if that fact is true. If it's false, you skip that part of your day and move to the next activity, like eating dinner. You can make similar agreements with your computer, except your computer can't take out the trash. We have to check smaller facts for truth, like does the number of lives the player has equal 0, or is the player currently in power-up mode? Notice that all of these are yes or no, true or false questions. You can make a code agreement with the computer to only do some things if the answer is yes or true. These agreements are called conditionals. They look like this. The first thing in the conditional is the fact to check, or the conditional statement. Here, the fact that we're checking is whether a variable named score is greater than or equal to 100. Notice that there are parentheses around the statement, score is greater than or equal to 100. These tell the computer where the true-false statement to check begins and ends, so they're important to have. Let's take a second to remember the previous video. We learned that variables can store true and false values. Now, we're learning that we can write statements that can be evaluated to either true or false. The kind of true and false that gets stored in a variable and the kind of true and false that comes from evaluating a conditional statement are the same. You can actually store the result of a conditional statement in a variable or use a true-false variable as a conditional statement of sorts. Here's a different way of writing the same if, but changing around how we handle the true-false values. If the score is indeed greater than or equal to 100, the computer looks for the next opening curly bracket to mark where its next instructions begin. These instructions are known as the conditional instructions. In this example, the conditional instruction is print you win. Notice that the conditional instructions are surrounded by curly brackets. It's important to remember these since they tell the computer where the instructions for this conditional begin and end. If the score is less than 100, the computer looks for the conditional's closing curly bracket to mark where its next instructions begin. This means that if the score is less than 100, the computer will not print you win. Sometimes, though, you don't just continue about your day if your conditional statement was false. For example, if you do complete your chores, you get to do fun things like see friends or play video games. But if you don't, your parent might add another chore to your list. Now we see that we can have conditional instructions in the case of true and the case of false. Let's walk through the example. Let's pretend that the variable score is storing the value 75 right now. First, we check the conditional statement. Is score greater than or equal to 100? No, it isn't, because it's storing the number 75 right now. Since it isn't, we look for the if's closing curly bracket. The computer starts to read the next line and sees the keyword else. The computer remembers that it just evaluated a conditional statement to false, so it knows that it should execute the else's conditional instructions, starting at the else's opening curly brace. So, instead of you win, the computer prints keep playing Space Ranger. However, pretty often when you're coding, you want to check multiple variables to help you decide what to do. You might want an object to move horizontally if its x position is less than 50 and its y position is greater than 10, but maybe you want it to move vertically if its x position is greater than 50 and its y position is greater than 10, and to move diagonally if its x position is greater than 75 and its y position is less than 10 and the price of beans in Albuquerque is $3. That covers a lot more cases than just one true and one false. The last tool in our conditionals toolbox is the ElseIf. You can use ElseIf if you have already used if but don't want to use else quite yet. You can use ElseIf as many times in between if and else as you like. Just remember that the computer will check your conditionals in the order you wrote them, from top to bottom and from left to right. It's also important to remember that the computer will only execute one block of conditional instructions from an if, else sequence. If you want to check two different conditional statements and possibly get to execute both of them, you should just use one if after another. ElseIf has conditional statements, unlike plain else. They're more akin to plain if than else because They only execute their conditional instructions if their conditional statement evaluates to true. The else in ElseIf just tells the computer that this conditional is one of an ordered sequence of conditionals. So the computer should evaluate if first, then the first else if, then if there's another else if, that one, and so on until it reaches an else, or it reaches closing curly brace on an else if that doesn't have another conditional after it. Let's walk through this example together. Let's pretend that the variable score holds the number -35. What would this conditional statement evaluate to? False, right? Because -35 is not greater than or equal to 100. Since this conditional statement was false, we look for its closing curly bracket and start reading again from there. The computer sees the keyword else if, and since it hasn't encountered a true conditional statement in this sequence yet, it evaluates the conditional. How about this one? True or false? It's true, because -35 is less than -20. So the computer executes the conditional instructions in the else if and then skips over the rest of the conditionals in the sequence. What would the computer print if we ran this code when score held the number -35? It would only print you lose, because only one conditional from the sequence has its conditional instructions executed. Let's look at something a little cooler that you can build with conditionals. This is a game that we made during our last hour of code, ages 11 through 14 workshop here at Code Ninjas Wellesley. It's called Brick Breaker. You move the paddle at the bottom of the screen with your arrow keys so that the ball never hits the ground and keeps breaking apart these blocks. Notice how if the ball hits the bottom of the screen, I lose a life. Here's the code that controls how losing lives works. The page loads with 3 lives and displays 3 little red hearts to represent those lives to the user. We subtract 1 from the player's lives every time the ball hits the ground using this function. We use if and else if conditionals to decide whether to change the hearts display or whether to end the game. Notice the conditional statement compares the game.lives variable to a specific whole number. Also notice that here we decided not to use an else, and we decided that the case of 3 lives wasn't necessary to write as an if or an else if, since the page loads with 3 hearts and 3 lives. We could write this section differently to include these things, but this works too. Now it's your turn to try using conditionals. Have you ever played PacMan? It's a classic arcade game. You're PacMan, this little round yellow guy, and you want to eat as many dots as you can. The dots are sprinkled through this maze. But you gotta watch out, because it's game over if a ghost catches you. However, if you eat one of these bigger dots, for a few seconds you can eat the ghosts yourself and eliminate a danger. To help you move around, you can go through one of these tunnels at either side of the maze and come out on the other side. Let's build our design skills. We have variables and conditionals in our toolbox now. Grab a piece of paper and a pencil, and let's write down everything we need to make PacMan. Feel free to pause the video after any of my questions or prompts so that you can write and sketch your thoughts. What variables would we need to make a PacMan game? Well, let's see. We'd want to know if PacMan was powered up or not. That sounds like a true-false variable. We'd want to know how long PacMan has been powered up if he's eaten a power-up dot. This sounds like a number variable, where we'd store the number of power-up seconds left. We'd want to know how many dots PacMan has eaten. That sounds like a number variable to me. We'd want to store the names and scores of the best players, so you can try to beat the scoreboard. Names would be letter and word variables, and scores would be number variables. We'd want to know for each ghost whether they've been eaten by PacMan or not, so we know whether they can be on the screen. That sounds like a true-false variable to me. Onto our new concept. What conditions would we want to check throughout a game of PacMan? We'd want to check if PacMan was touching a ghost, and whether he was powered up or not at the time. What are the different possible scenarios here? Powered up or not, and touching a ghost or not? What would the conditional instructions be in each scenario? We'd want to check if PacMan was touching a tunnel entrance. What would we do if he was touching the left tunnel entrance? We'd want to check if the player beat any high scores after their game ended. What would happen if they did beat some high scores? We'd want to check if PacMan was touching a dot so he can eat them. How does PacMan eat dots? We'd want to check if PacMan hit a maze wall so he couldn't move through the walls. What tools do you have to check for this situation? How could you add the check into what you've already written, for example, how he moved, in order to stop him from moving through the walls or off the screen? Thanks for watching, and good luck with your conditional capers.